Hey guys, this is the first video on limits involving infinity, and this lesson will focus on vertical asymptotes. When we encounter a function with a vertical asymptote, like this function here graphed in blue, f of x, we can assume several things. As x approaches the location of the vertical asymptote, we know that the value of the function f of x tends to either positive infinity or negative infinity. The second thing we know is that the graph never, ever crosses a vertical asymptote. Right? We know that in this particular case, if x equals a is the vertical asymptote, that a is definitely not in the domain of f. Right? That means the following from a calculus perspective. If we have a one-sided limit as x approaches a from either the right or left, and that limit goes to plus or minus infinity, and we know we have a vertical asymptote at x equals a. So suppose we want to find these limits involving infinity and we have a graphing calculator available to us. Let's take a simple function with a vertical asymptote like 1 over x. Because f of x equals 1 over x is one of those functions that you really should know before coming into the course, you ought to be able to sketch its graph. It looks like this. Because we're familiar with the graph and we know where the asymptote is, we can make the following two claims. We know that the limit as x approaches 0 from the right of f of x is infinity, because the graph of f as x gets closer and closer to 0 from the right continues to increase without bound. As well, we can also claim that the limit as x approaches 0 from the left of f of x is negative infinity. Again, because if we're coming towards x equals 0 from the left side, we have negative values. The graph gets more and more negative as we get close to 0, and so it tends to negative infinity. Alright guys, finally if you take a look at the table of values here, again I've just plotted a few. You can sort of see my notes here, but 0 is the middle value here in the table. Of course, because 0 is not in the domain of f, it produces an error. And then the black notes here as x is going to 0 from the left side. You can see that as it gets closer and closer, it gets more and more negative. Similarly, the blue part, as x approaches 0 from the right, as x is getting closer and closer to 0 from the positive side, the values of f are getting very large.